Hello student, today we are going to discuss about the chapter gravitation. Okay, so before we discuss about gravitation, we should know some phenomena that we usually see in our daily life. Suppose when you throw a ball, what happens to the ball? The ball usually goes to some certain height and then the ball comes back. Why does the ball come back? This means that something is there, okay, which is pulling the ball back to the earth. That means the earth is pulling the object, that is the ball here. Okay, that means there will be, if the earth is pulling the object, that means there will be some force of attraction between the earth and the ball here. Similarly, when we see the moon and the earth, you can see that the moon is to revolve around the earth. Similarly, if you compare the earth with the sun, we can see that the earth is revolving around the sun. So it means, now if you say that why the moon is revolving around the earth, it means that the earth is pulling the object, that is the moon, and due to the force of attraction, what is happening here, the moon is revolving around the earth. That means that between any two objects of our universe, there is a force of attraction between them, and this force of attraction is known as the gravitational force of attraction, or in a very simple word we can say here as the gravitation. So the definition of gravitation is the fundamental force of attraction between any two objects of the universe which have some masses. Now this is particular theory which is we are discussing here, okay, between in the late 16th or 17th century. At that time it was not known. So there is a very interesting story related to the topic called gravitation here. So once it was said that Newton was sitting under a apple tree. So when you are sitting under an apple tree and thinking something or imagining something, at a very particular moment an apple fell down. So as a student or as a human being, what will you have done? Okay, what you will have done? You would have taken the apple and eat it up. Okay, but the Newton did not do that. Instead of eating the apple, he started to think that why does the apple came downward? Why don't it go upward? And his thinking and the research and the theory that he can produce afterwards, okay, then he came to a conclusion that there is nothing but the gravitation. This gravitation or the gravitational force of attraction is pulling the object towards the earth here. So after doing the image study, okay, the Newton came to a law, and this law is known as Newton's law of gravitation here. So what does the Newton's law of gravitation say here? Newton's law of gravitation says that every object in the universe are attracted to each other by a force of attraction, okay, and this force of attraction is directly proportional to the product of masses of the what, of both the object, and it is inversely proportional to the square of the distance between them. Suppose now the two objects, okay, let us prove the theory here. Now I have taken here two masses. Let the mass of the object be m1 and m2, and they are separated by a distance here as r. That is your wish. In our book they are given small m and capital M, and the distance is denoted by d here, okay. That is you can change it, you can make it m1 and m2, and the distance you are taking it as the r here now. Now let us consider two objects, that is A and B, and they are having a masses of m1 and m2, and they are separated by a distance here r. Let F be the force of attraction between these two objects. Now, according to Newton's universal law of gravitation, if you just go to the law, what does it say? The force is directly proportional to the product of masses. That is, F is directly proportional to m1 into m2. Make it equation number 1. Then again they say the force is, you can just take it out here. They are given there the force is what? Universally proportional to the square of the distance between them. So that is F is inversely proportional to the square of the distance, that is your r square here. Equation number 2. So when you compare both the equation, you will be getting here that F, from this to F, you will take the F here, proportional sign, m1 into m2 divided by what? R square. Now in the last chapter also we have discussed that whenever we get any proportional sign, we have to remove this proportional sign. To remove this proportional sign, we need to bring some constant. In the Newton's second law of motion, we put the constant as K here, but here the constant will be your G here. So what will happen here? F is equal to G into M1 into M2 by R square, where G is the universal gravitational constant and its value is found to be 6.67 into 10 to the power minus 11 nm square by kg square. Okay, and this value was found after doing lots of experiment. Okay, so now our next topic is going to be how to find the SI unit of the universal gravitational constant. So the next thing that we are going to discuss is the SI unit of G. Okay, so now you see, okay, in my previous classes also I have already said that you don't need to learn the SI units. Okay, some of them you can keep in your mind, and in case if you forget the SI unit, you can take out the SI unit by yourself also. So today we are going to learn that how to take out the SI unit of any other given quantity here. So now our aim is to find the SI unit of G here. So what I can write here? I can write here F is equal to G into M1 into M2 by R square. That is, I need to find out G. So I need to take the G in one particular side here. Okay, either left hand side or right hand side here. So what I can do here? I can do the cross multiplication. I'll be getting a G into M1 into M2 is equal to F into R square. Now G is equal to F into R square divided by M1 into M2 here. Now once you can bring the G in R1 side and you can take the other given quantity on the other side, you can find out the unit now. Now just take it out. This is what? F. F means your force. We know that the SI unit of force is Newton, that is N. Then this is your R of your distance. Okay, we know the SI unit of distance is what? Meter. So it is distance square, so it will become your meter square. Then divided by M1. M1 was the mass. What's the SI unit of mass here? Mass is kg, and here also M2. M2 is also the mass here. Second will become your kg here. So what will I get now? N m square divided by kg into kg means kg square. That is n m square. If you bring it outside, the positive power will become your negative power. So it will become nm square by kg square. Or we can write like this also, nm square by kg square. So now if you check this unit with the given unit that I discussed in the previous, when I was telling that the value of G was how much? 6.67 into 10 to the power minus 11 nm square by kg square. You can check it out. This is nm square by kg square. That was what I got here, nm square by kg square. So in this very particular way, you will be able to find the SI unit of any other given quantity. So now whatever we have discussed, that is the Newton's universal law of gravitation. Okay, on the basis of that theory, we are going to solve our first question from the page number 143. What they are saying here? How does the force of gravitation between two objects changes when the distance between them is reduced to half here? So first of all, you should know that what is the formula for force. So we know that force is what? F is equal to capital G into M1 into M2 by R square. Just make it your equation number 1. Now according to question, you just come and just check it out here. What they are saying here? They are saying that how does the force of gravitation between two objects changes when the distance between them is reduced to half. They are not talking about the mass. Okay, they are not talking about the mass. M1 and M2 will be constant like before. But what they are changing here? They are changing the distance. This distance has been reduced to what? Half here. That means this R value will be reduced to half here. So now let's see that what's going to happen here. So now since the distance have been changed here, so we cannot use the value as R here. Okay, we have to take it some other symbol. You can take it R1 or you can take it R dash. Okay, so now you can write here new distance, that is R dash. Now you can just take it out. What they are saying here? Distance between the object is reduced to half. Half of what? Half of the previous distance. The previous distance was our R only. So that means now since the distance have been reduced, so obviously there will be change in the force here. So you cannot use the force F again. Okay, we have to use F dash or F1. So you can write here new force, that is your F dash, is equal to capital G. Remember here M1 and M2 is not going to get change. It is going to be same here. Okay, what is going to change? The radius here. Okay, so now you can check it out. Our new our new distance was r1. Okay, so your r dash whole square here. So what we can write here? F dash is equal to capital G into m1 into m2. R dash means what? 1 by 2 of r. That will become your whole square. That is F dash is equal to capital G m1 into m2 divided by r square. 2 2 will become what? 4. Now you can see here, this is our main line of fraction. This is down and this is down to down. If this is down to down, where it should go? It should go up here. That means F dash is equal to 4 into G into m1 into m2 by r square here. Now if you go more further, what you can see, 4 then 4. Now check it out. G into m1 into m2 by what we have here? R square. Just check it out here. F G into m1 into m2 by r square. Now this is equal to whom? This is equal to F here. That means in place of this particular thing, what we can write? F. That is, we can write here F dash is equal to how much? 4F. Now this 4F means the new force is going to be what? 4 times of the previous force. So how to write at the end? Therefore, the new force is 4 times of the previous force. Okay, so there are many questions related to particular topic. This very particular topic. Okay, you will be getting the questions as a homework. So our next question is question number 3. They are asking us what is the magnitude of the gravitational force means. Already we have discussed. Whenever there is a magnitude, that means they are telling us to find out the value of the force here. Okay, that is gravitational force between the earth and a 1 kg object. That means there are 2 objects are there. One is your earth, other one is your object here. Okay, so the object mass they have given here 1 kg. So distance will be calculated from the here. Suppose like this object will be something here only. Okay, so this will be the distance between the object and the earth. Okay, center of the earth. So this distance is nothing but the radius only. So now the mass of the object we have taken here. Mass of the object m1 is equal to 1 kg. And on its surface they say means it is center of the earth here. The mass of the earth we have taken here as m2, that is 6 into 10 to the power 24 kg, and the radius of the earth, already we have said that radius of the earth is nothing but the distance. Okay, so radius of the earth I have taken r equal to 6.4 into 10 to the power 6 meter here. So they are telling us to find out the force. So we have to go to the formula for force here. We know the force F is equal to capital G into m1 into m2 by r square here. Now slowly we try to put the values here one by one. F G, okay, already we have said G value, G is a constant here, so its value is not going to change. Anywhere in the universe if you go, no matter, the value of G is going to be always same here. So what we have now learned before, what is the value here? 6.67 into 10 to the power minus 11 nm square by kg square. Don't forget to write the unit also. We will be writing the unit only for the one time. Afterwards, at the end we are going to put the unit. Okay. Now into mass m1. What is m1 here? 1 kg. And what is the mass m2 value here? 6 into 10 to the power 24 kg here. Divided by r value is how much here? 6.4 into 10 to the power 6 meter whole square. Now F is equal to 6.67 into 10 to the power minus 11 into 1, because you know to write 1 because 1 multiplied with any other number will give you the same number again. So no to write 1 again here. So you can write here 6 into how much? 10 to the power 24 divided by. How much we are going to have here? 6 point, because it is square here, write here 6.4 into 6.4. 10 to the power 6. Okay, this is 6 and this is to me 6 to the how much here? 10 to the power 12 here. Now write 6.67 into 10 to the power minus 11 into 6. Okay, and this is how much here? 10 to the power 24. Now this is how much here? 10 to the power 12. This is positive, isn't it? Now take it outside. We know that when you take the power from down to up, the plus become minus and the minus become plus. So since it is plus, it will become minus. Divided by how much? 6.4 into 6.4. 4 here. Now, slowly try to sort it out. F is equal to, just leave it like this, 6.67 into 6. Now we know, you can see here the 10, what is the base here? 10. Here also what we have? 10. Here also what we have? 10. Now we know that if the powers have same base, then the power is to be added here. Okay, so what you can do here? 10 to the power minus 11 plus 24 minus 12 divided by 6.4 into 6.4 here. Now just take it out here. What we have value here? 6.67. That means after a point, how many digits are here? 2 digits. Come downside, you can see here we have 6.4 and here we have 6.4. So here also 1 digit, here also 1 digit. 1 plus 1 becomes how much? 1 plus 1 becomes 2 here. That means outside also after point we have 2 digits, downside also after point we have 2 digits. Then in this type of situation, you can directly remove your point. Okay, there is a decimal here. So you can directly write here 667 into 6 into 10 to the power. How much are you going to get? 24 minus 11 will become 13. 13 minus 12 will become 1. So we can write here 10 to the power 1 divided by 64 into 64 here. So if you want, you can cancel it out. 3 times, 32 times, 16 times, and if you cancel it out, you are going to get 5 here. That means F is equal to 667 into 3 into 5 divided by 16 into 64. Now if you multiply and if you do the division, okay, so let's see what the answer you can get here. 667 into how much? 15. 7 5 is 35, 5 3 in hand. 6 5 is 30, 31 is 33, 3 in hand 30, 33. 7, 6 and 6. So 5, 0, 6, 7, 8, 9, 10, 0, 1 in hand. Again 10 here. 1, 0, 0, 0, 5 divided by 64 into 16. 6 4 the 24, 4 2 in hand, 6 is the 36 and 7 38, 4 and 6. 4, 2, 6, 7, 8, 9, 1, 10. That is 1, 0, 2, 4. So if you divide, you are going to get something around 9.7 approx. Okay.
Stay home, stay safe, do it for yourselves, do it for your family, do it for India. Let's break the chain of COVID-19. Hum hong liye kamyab. Jai Hind.